Welcome back, everybody. This is our video solution to problem 5 from quiz 2, the final problem from the quiz. And in this problem, we're actually given two integrals that we want to compute, only this time we're allowed to use the fundamental theorem of calculus, right? We're going to use the second fundamental theorem, also sometimes called the evaluation theorem or the net change theorem, all sorts of names for it. But the whole idea of it, of course, right, is if you have an integral from a to b, and you can identify your function as a derivative, then you can compute the integral by finding an antiderivative, and then looking at the net change between the antiderivative at the initial point and the terminal point, right, between a and b. All right, so we need to see this function as a derivative of something, meaning we need to find an antiderivative. So let's see, an antiderivative for t to the 2/3. So we're just using the power rule on that thing. We get t to the 5/3, and then we divide by 5/3, which is the same as multiplying by 3/5. Plus, all right, let's see, we evaluate, or we antidifferentiate t, we're going to get a half t squared. And then if we antidifferentiate 1, we're going to get t. And we take all of that and we're going to evaluate it between 0 and 1. All right, well, it's pretty easy to evaluate it at 1. When we evaluate it at 1, all of these t's to an exponent are just going to become 1. So we actually just get the coefficients. So we get 3/5 plus 1/2 minus 1. Now we need to subtract what happens when t equals 0, but this is fantastic. When t is equal to 0, I'm going to get 0 to a power times something, 0 to a power times something, minus 0. 0 plus 0 minus 0, like all that's 0, right? So we're not worried about that. Cool. So now it's just a little bit of arithmetic. Let's see, this is going to be 3 times 2 is 6, plus 5 is 11 over 10, minus 1. 1 is 10 over 10. So this is 1/10. Awesome. Okay, first integral completed. How about this second integral? All right, well, let's move this out of the way a little bit. Okay, so for this one, we want to find an antiderivative of this function, but it's a little more complicated looking. So maybe we want to do a little bit of auxiliary work first. So let's go to the side. And let's just say we wanted to find an antiderivative for 3t squared times the sine of t cubed plus 1. Now I don't know it immediately, but I do have this tool that I've worked on, which is substitution. So with substitution, I look for a function and its derivative. And the first thing I notice here is there's like this t cubed. Okay, I could add 1. That doesn't hurt anything. And its derivative is 3t squared, which is right there. So I'm going to do a substitution. Right? We'll switch over to a different color. And we'll say, okay, how about u equals t cubed plus 1, so that du is 3t squared times dt. Okay, so if I make that substitution, then my antiderivative becomes, well, let's see, sine of t cubed plus 1. That's just going to become sine of u. And then 3t squared dt, that just becomes du. And I know an antiderivative for sine. It's negative cosine. Very good. And then I can put this back in as negative cosine of t cubed plus 1. Excellent, I have an antiderivative. So this is going to be negative cosine t cubed plus 1. And then we need to evaluate between pi over 6 and pi over 3. And okay, it's just going to be horrendous, but we can write it down. Negative cosine pi over 3 cubed plus 1. And then we need to subtract, and because there's already a minus, this will become a plus, cosine of pi over 6 cubed plus 1. And I'm not going to go any farther than that because I don't know how to simplify these at all, right? I mean, I can make this pi squared over 27, or rather pi cubed over 27 plus 1, but I'm not going to know how to take the cosine of that. So we're just going to leave it right here. That's as far as we're going to go. Okay, so we can use the fundamental theorem, right, in very straightforward applications. Sometimes we may want to do a little auxiliary work to find that antiderivative, right, because that's the key step. So we might do a little bit of that on the side, and then we can plug it back in to our original, like flow, right? So hope this is helpful for you, and we'll see you next time.